Hello guys, welcome. In today's video, we are going to discuss about triangles. Let me remind you that in previous video, I think it was the first video which I've discussed, that I've told you that some of the portion from triangles has been deleted. Okay. And another thing you need to remember about this chapter is that most of the question asked are theorems. Okay. They used to ask two theorems, out of which you have to attempt one. Okay. So this chapter is triangles. And today we are going to discuss about theorems of triangles. How many theorems are there? There are total 10 theorems. Okay. But thanks to the corona some sort, that our syllabus has been deducted. Okay. And now we have only 6 theorems. Okay. Those theorems are 1, 7.1, 2, 3, 4. I think so 5 is deleted. Theorem number 6 and theorem number 9. The rest are deleted. Okay, so let us go step by step. Let us look upon theorem 7.1. Let me remind you once again, these questions are compulsory. Okay, you are going to get these questions in the exam, from which you can secure 5 marks very easily. So let's start. Theorem number 7.1. Okay, what does it say? Let me tell you once again. For mathematics, the first thing you need to understand is the question. If you can crack the question, okay, it will be easy for you to understand how to solve it. Okay, first thing you must understand is the question. Okay, you have to understand the question. So let us study 7.1. Let us understand it properly, step by step. Okay, before understanding this, you need to understand three things. First is sides. Okay, another is parallel, and third is intersecting. Okay, sides. What are sides? So you just give this triangle and name this triangle as A, B, C. Okay, what are the sides of this triangle? A, B, A, C, and B, C. What are the sides? A, B, A, C, and B, C. These three are the sides of this triangle. Okay, now another thing, parallel. What is parallel here? Parallel. Any two lines, okay, which will not meet in near future. Okay, two parallel lines. These two are parallel. Simple, right? Now third, intersecting. What is intersecting? This is intersecting. Okay, any two line, okay, which meet with each other at particular point, that is intersecting. Okay, you can say this also as intersecting. So I hope this is clear to you. Parallel, sides, and intersecting. Now let us look over the question. The question says, if a line is drawn parallel to one side of a triangle intersecting the other two sides, then it divides the other two sides in the same ratio. Okay. Now what does it mean? Let us understand. If a line is drawn parallel to one side of a triangle, what are the sides of a triangle here? AB, BC, and AC. Let us take the one side as BC. Let us take this side and let us draw a line parallel to BC. Okay. Let us name this triangle which is drawn parallel as DE. Okay. Now, if a line is drawn parallel to one side of a triangle, now DE is drawn parallel to BC according to the question, intersecting the other two sides. Okay. Now, you may say that, okay, we can draw parallel to BC as like this also, down here also. Okay, for this we can't do this because our next statement, that the parallel line must intersect AB and AC. Okay, the other two sides, it must intersect. Okay, I hope that is clear to you. Okay, now let us solve the question. Okay, now let us solve the question. Question says, we know these things. Now what does it say? Then it divides the other two sides in the same ratio. If D is drawn parallel to BC and D is intersecting AB and AC, then the ratio AD by DB will be equal to AE by EC. This is the question. So let us solve. Okay, let us take this triangle again once again so that it will be easy for us. Let us name this as A, B, and C, and let us draw a line parallel to this one, ABC, DE. Okay. Okay. Now it's simple. We have to write, before solving, let us write the given one. What are given? Triangle is given, ABC. Triangle ABC is given. Okay. Another, what is given? D and E lies in AB and AC respectively. Okay. Okay, D is lines where DE is parallel to BC. All these are given. Okay, D is parallel to BC and D is in AB, E is in AC and ABC is a triangle. This much is okay for you. Now to prove, what do we need to prove? To prove, what is the thing that we need to prove? AD by DB must be equal to AE by EC. Okay, construction. What are the construction that you are going to make? Join BE. What the hell is this? Join BE. Join DC. Okay, we have joined the two line. Now done. Now another thing is draw a perpendicular here. Okay, and draw another perpendicular here. Okay, now the question here says this DE is parallel. Okay, now let us name this as E, F and G. Okay, F and G done. Now construction, what we have done? Join BE and CD. We have to join both the line. What is the another thing we need to do? Make CF perpendicular to AB and BG perpendicular to AC. FC must be perpendicular to AB and BG must be perpendicular to AC. I hope it is clear to you. Okay, now let us go forward and let us prove. Okay, proof. Let us do the proof. Now, simple. If let us take triangle, let us assume a triangle. Okay, triangle BDC and triangle BEC. These two triangles, the area of these two triangles will be equal. Why? I'll tell you. Okay, so area of triangle DBC is equal to area of triangle EBC. These two triangles are equal. Okay, now the next thing. Okay, what are the next thing that we need to do? Now since these two triangles are equal, why these are equal? Because they are under the same parallel line. If they are under the same parallel line and under the same base, this is both are under the same parallel line. Okay, look, these two are in between the same parallel lines and the base BC is common to both. That means their area will be same. Okay, that is our theorem. That is our theorem. That is something you need to know. I think you have learned in class 9 some sort. Okay, so we have done. Now therefore area of triangle ABC. Where is triangle ABC? This whole triangle. Okay, ABC, this whole triangle minus area of triangle DBC is equal to area of triangle ABC minus area of triangle EBC. So far clear. Okay, now area of triangle ABC minus, if you take the whole triangle and if you minus this one, must be equal to if you take the whole triangle and if you minus this two. Simple. It's not that complicated. I think you can understand that also. Okay, now what are we going to do? Area of triangle ABC, from this whole triangle you remove this portion DBC. You can know this DBC, area of triangle. From whole triangle you remove this one. What will be left out here? This one. Okay, so it will be area of triangle ADC, which will be equal to area of triangle. From this whole triangle, if you happen to remove this one EBC, then this will be left out, is it? So let us write down ABE. Anyway, ABE. So these two are the triangles which are similar. Okay, which are equal. Okay, so this is the first one. Let us remind it as equation number 1, and the second one as equation number 2. Okay, now let us divide equation number 2 by equation number 1 by 2. Okay, after dividing equation number 1, let us divide equation number 1 by equation number 2. So if you happen to see equation number 1 by 2, area of ADC by area of triangle DBC. Area of triangle ADC divided by area of triangle DBC, which will be equal to area of triangle let me write down and let us copy this one, EBC ABE, ABE by EBC, ABE EBC, ABE EBC. Do not worry that like something like this area of triangle ABE can be written as AEB. I think it is given in textbook like that. Don't get confused, you can write your way, okay? It's not that means compulsory to write according to the book, okay? So area of triangle ADC. Now what is the thing you need to understand here is area, okay? Area of a triangle. What is the formula for area of a triangle? Area of a triangle, one of the formula is half into base into altitude, half into base into altitude, or half into base into perpendicular. Okay, we can write altitude as perpendicular, do what the hell you want, but remember the formula. So half into base. What is the base of ADC? ADC, base is AD. What is perpendicular? FC. So half into base AD into FC divided by area of triangle DBC. Look here, triangle DBC, D. Where is triangle DBC? Look here, triangle DBC. Half into DB into FC. Half into DB into FC. Area of triangle ABE. What is ABE here? ABE. It is base is AE and perpendicular is BG. Half into AE into BG. And half into second triangle, that is EBC. What is EC into BG? Half into EC into BG. So I hope it is clear to you. Okay, it's not that complex to understand, it's quite simple. Okay, now let us do the cancellation and all these things. Okay, half can be cancelled, these two are out, FC can be cancelled, this is also out, half cancel out, BG cancel. So therefore AD by DB is equal to AE by EC. Congratulations, we have got the answer, and this is hence proved. This is the thing which you need to prove. You can just look here in to proof. We need to prove this, and we have proved. So done with question number 1. Let us go to theorem number 2, 7.2. Let us do a little bit faster because I think the video will go quite longer. So let us see theorem number 7.2. What does it say? Let us understand the question first. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So let us give the name as ABC. A, B, and C. This is a triangle. Now if a line divides any two sides of a triangle, okay, if a line we have drawn, okay, now the line divides any two sides of a triangle. Now line, this is the line and this line, okay, let me, horrible line. Okay, now DE, we have drawn a line DE, okay. If a line divides any two sides of a triangle, now this divides these two sides of a triangle in the same ratio, that is AD by DB is equal to AE by EC. Okay, this is given. Okay, we need to prove this is given. Okay, to prove, we need to prove that DE is parallel to BC. The first theorem is called basic proportionality theorem. the which we have done 7.1, and this is called converse of basic proportionality theorem. It is just the reverse of before one. Okay, in before question it was given that parallel is there. We need to prove this one. Now this one is given, ratios are given, and we need to prove it is parallel. Okay, I hope I'm not making much complex, and it is easy. I think so. If not, you write in the comment below. I'll try my level best to explain further in the next coming video. Okay, now so far this much is okay. Okay, I hope you understand so far. Now let us do the construction which you need to do. Okay, let us take the next page. Okay, let us draw a line A, B, C, and this is D, E. Okay, now given, what is given? AD by DB is equal to AE by EC is given. To prove, what we need to prove? To prove DE is parallel to BC, we need to prove. Construction, we are going to draw a line, a new line, may it be DF. We are going to draw a line from D. Okay, draw a line from D such that it is parallel with this one. Let us draw a line. Okay, assume that DF is parallel to BC. Okay, if DF is parallel to BC and we need to prove DE parallel to BC, then F and E must be on the same point, otherwise it won't be parallel. Okay, so construction, we have drawn through D, draw DF parallel to BC. Okay, meeting AC at F. Okay, we have drawn, construction done. Now proof, let us start our proof. We know by basic proportionality theorem, the before theorem, that if these two, okay, you just forget so if triangle is given and if this is parallel, DF is parallel, this is ABC, okay, then according to by basic proportionality theorem, by first theorem or basic proportionality theorem, right, anyway you want, first theorem, AD by DB is equal to AF by FC. Clear, right? And this is okay. Now another thing is given in the question. What the question says us about DB is equal to AE by EC. So let us assume this is 1, this is 2. From 1 and 2, okay, these two are same, right? Left hand side is same, so right hand side also will be equal. So we can write from 1 and 2, from 1 and 2, AD, what am I writing? AF by FC, this one, this portion must be equal to AE by EC. So from equation 1 and 2, AF by FC, which will be equal to AE by EC, AE by EC. So we got so far till here. Okay, now let us add 1 to both sides. You'll understand why, okay, while doing this. Okay, AF by FC plus 1 equal to AE by EC plus 1. Okay, now adding AF plus FC divided by FC is equal to AE plus EC by EC. Okay, AF plus FC, what is AF plus FC? AF plus FC, AF plus FC, this is whole AC, right? So we can write this as AC by FC is equal to AE plus EC. What is AE plus EC? AE plus EC, this one AE plus EC, same thing, it is also AC, AC by EC. I hope it is clear to you. Okay, now AC can be cancelled, you do the reciprocal, you get FC is equal to EC. Now we know DF is parallel. We have drawn already by construction DF is parallel. Okay, now we need to prove DE is also parallel. So for that to be equal, AF FC must be equal to EC. If this one is equal to EC, then our lines are parallel because before DF is parallel. Now if these two are in the same point, then DE also will be parallel. So we are going to conclude from that FC is equal to EC. Therefore, so let me draw a line so that I can write it. So we can say F coincides with E. Okay, from this we can write FC is equal to EC. We can write F coincides with E. Another, DF is parallel to BC. Okay, according to construction, by construction. Okay, we have constructed such that it is parallel. Okay, don't say how it can parallel, by construction only. So therefore, or DE is also parallel to BC. Okay, hence proved. Hence proved. I hope it is easy. This is quite simpler. Okay, let's not waste the time. Let us go and do another question. That is 7.3, theorem number 7.3. The internal bisector of an angle of a triangle divides the opposite side internally in the ratio of other two sides. Okay, let us do theorem number 7.3. Internal bisector. Let us understand what is bisector means. Okay, if you take any angle, okay, and if you divide the angle such that this angle and this are equal, then this is called internal bisector. Okay, now here internal bisector of any angle of a triangle, bisector on angle of a triangle. Let us draw a line, straight line. Okay, this angle is equal to this angle. Simple. Let us name it as A, B and C, and this is D. Okay, A, B, C and D. These two are equal. Now another thing which we need to consider, divide the opposite side internally in the ratio of other two sides. If we divide such thing, then BD is equal to BD. Now what will happen? BD by DC will be equal to AB by AC. What does the question says? If we happen to divide any angle of a triangle, okay, internally, if you have to bisect any angle of a triangle, then the line which joins the other side, the sides ratio BD is equal to BD by DC will be equal to other two sides ratio AB by AC. I hope it is clear to you. Okay, this is the statement which we need to prove. So let us start. Okay, let us do by given. What is given? A triangle is given. Okay, and A, B, C. A, D. So given, we are given with the bisector, internal bisector AD. Okay, AD bisects angle BAC. Okay, angle BAC means, or angle A, you just say name it as angle A, as it is in book, I think so. So of triangle ABC meeting BC at D. Okay, the AD is bisecting angle A and meeting at D in the line BC. I hope it is clear to you. Okay, now to prove, what we need to prove? We need to prove that AB by AC is equal to BD by DC. Look here carefully. AB by AC is equal to BD by DC. It is clear to you. Now construction. Let us do the construction. What is the construction we need to do? We need to draw a line touch from C. Okay, draw a line from C. Okay, which is parallel to DA. Draw a line from C. I don't know how to draw the line in this board. Okay, such a crooked line. Let me just draw it, you'll understand. You just look in the book, okay, for clear diagram. Yeah, this is also too much again. So, okay, I've drawn a line, okay. This line is parallel to DA. Just think that it is not parallel, actually. I haven't drawn that way. So, let me draw for this one. I can draw for this one, okay. Let me draw for, so that it will be, so this is E. Assume this is E. And now extend AB. Extend AB to E. Okay. Extended AB to E. Okay. This is the construction. What is the construction? Construction, we are going to draw CE. CE is parallel to AD. And AD is extended to E. Okay. I hope it is clear. Now, let us start our proof. Okay, by construction, DA is parallel to CE. Okay, we have drawn the construction so that is. Now, if the DA is parallel to CD, then what is our theorem? What is our basic proportionality theorem says? Basic proportionality theorem says BA by AE will be equal to, okay, BA by AE will be equal to BD by DC. Okay, we need to prove AB by AC is equal to BD by DC. So let us write BA as AB. Okay, we can write, okay, BD by DC. Now if we replace AC here, AC and AE, only this. If we are going to prove that AE and AC are equal, okay, if these two are equal, then we can replace AE by AC, so we can prove the theorem. I hope it is clear to you. I think I'm telling too much. It's clear to you. Anyway, okay, let us go forward and let us see the answer. So let us write this as 1. Okay, now DA is parallel to CE. Okay, then angle, look again, if two, so listen. Now before understanding the further thing, let me make you understand today. These two are parallel, then let us draw a line. Then this angle will be equal to this angle. Okay, or this angle will be equal to this angle. This one, yeah. These two angles will be equal. This will be equal to this one, and this angle will be equal to this one. Okay, so these are the things between two parallel lines. Okay, now since here AD is parallel to EC, okay, these two are parallel, then we can say angle BAD, this angle, okay, is equal to angle AEC, this angle. Okay, since these two are parallel, these two angles will be equal. Okay, now another thing, AD is parallel to EC. Okay, another thing is again that this angle, okay, DAC, angle DAC, this angle DAC will be equal to ACE, this angle also. I've told you how, is it? Two parallel lines, so these two are equal. Angle DAC is equal to angle ACE. Okay, I hope you are opening the book, textbook at least, so it will be easy for you to little bit connect, because it's not that good to write in this screen. Okay, I'm finding quite difficult to write in the screen. I think it will be heavy. It will be heavy soon, but now I'm finding it difficult. Okay, not that habituated to write in this kind of screen. So we have written already. So what are the thing? Angle BAD is equal to angle AEC. This was one, and angle, what was another? DAC is equal to angle DAC is equal to angle ACE. Okay, this is 2. Okay, now we have written both the equations. Okay, 1 and 2 or 2 and 3. This can be given 2 and this can be given 3. Okay, now AD okay, AD actually bisects, okay, AD actually bisects angle BAC. So BAC and BAD and BAC, look here, we know from before that this angle and this angle are equal because AD is bisecting this one. Therefore we can also say angle BAD is equal to angle DAC. These two angles are equal, okay. So angle BAD DAC, angle BAD is equal to angle DAC. These are also equal. So we can say this and this are equal. So we can say, if these two are equal from equation number 4, then these two also will be equal. AC is equal to ACE. So angle AEC is equal to angle ACE. Okay. Now, since these two are equal, let me go forward. AEC, ACE. This angle and this angle are equal. Okay. If any two angles of a triangle are equal, then its opposite sides also will be equal. If any two angles of a triangle are equal, then its opposite sides are also equal. Okay. I hope you know this. Okay. So, if these two angles are equal, we have already written, then our sides, this side and this side also will be equal. So we can write AE is equal to AC. Therefore, AE is equal to EC. Put this in equation number 1. Okay. What does our equation number 1 says? Equation number 1, this one. AB by AE is equal to BD by DC. Let me write down here once again. AB by AE is equal to BD by DC. Now instead of AE you can write EC. So AB by EC is equal to BD by DC. Okay. I hope you can look to this one. Okay. Now this is what we wanted to prove from before. Okay. This is the thing that which you need to prove from before. Look here to prove. We have proved already AB by AC is equal to BD by DC and AB by EC, AB by, what have I written? AB by AC, okay. AB by, what have I written? AE is equal to, AE is equal to AC. This is AC, okay. Sorry for that mistake. So here will be AC. So this is hence proved. I hope you understand. If you don't understand, you just let me know, okay. Theorem number 7.4. Let us look at theorem number 7.4. It is also called triple A similarity, angle similarity. Okay, what does it say? I have told you again and again. Okay, even now I am telling you that if you are learning mathematics, okay, the first thing you need to understand is the question. So let us look into the question very carefully. What does the question says? If the corresponding angle of two triangles are equal, then the triangles are similar. If the corresponding angle of two triangles are equal, then the triangles are similar. If angles, corresponding angle, this angle is equal to this angle, these are corresponding angle, or we can say this angle is equal to this angle, this is also corresponding angle, or we can say this angle is equal to this angle, this is also corresponding angle. If such thing, if any one of the corresponding angles are equal, then we can say that these two triangles are similar. So we can say, we can conclude that if these two angles are equal, then this triangle is also similar. Okay. So let us look upon it. Okay. Let me open my pages to exactly that one. Okay. Now, what are the given condition first? First, we need to write down is given. What is given? Two triangles are given. Name it ABC and DEF. Okay. Now, one thing we need to understand is angle A is equal to angle D. Angle A is equal to angle D. Corresponding angles are equal, right? So angle B is equal to angle E, and angle C is equal to angle F. Okay. These are the corresponding angles which are equal with both the triangles. Okay. These corresponding angles are equal. So we need to prove. To prove. What do we need to prove? Triangle ABC is similar with triangle DEF. This sign shows that it is similar signs. Okay, this sign is for similar sign. Okay, now construction. Let us draw a line Mn, okay, Mn, such that M and N, let us draw a line Mn such that M lies in AB and N lies in AC, and this okay, this particular Mn, okay, is equal to this particular Mn, that is AM and An are equal to DE in the F, okay, it is equal to with this, okay. So we can write, given in construction, you can just write it by your own, I don't have space even to write, so you just write it down, okay. Mn is constructed in such that AM is equal to DE and AN is equal to DF. All these things you write it down, okay. It is quite simple, you just do it. So I think it is clear so far. Let us start the proof, okay. Now doing the proof, okay. Doing the proof, the first thing you need to understand doing the proof is that the triangle which we have drawn, the angles are equal. Angles are equal, no doubt. Angles, all angles are equal, corresponding angles are equal. But it is not necessary that all the sides are equal. The sides AB may be greater than DE, the AB may be shorter than DE, or it is equal. There are the three cases remaining, okay. So this question can be discussed in three cases: case 1, case 2, and case 3. Okay, angles are equal but sides may not be equal, and for inequality of sign, it may be that AB doesn't equal to AB is greater than DE, or AB is equal to DE, or AB is less than DE. So it is possible. Three conditions are possible. So let us take the case 1, and let us take this triangle as case 1, and let us solve. Okay. Case 1. Okay. Now M, here look here carefully. M lies in AM. M lies in AB. Okay. Now in triangle ABC, in triangle, okay, AMN, no ABC actually. In triangle AMN, okay, and DEF. Okay, look these two triangles, AMN and DEF. I hope you are opening the textbook. You need to open the textbook. It will be easier for you. I'm just going to jump and just explain only. Okay, I'm not going to do all the questions because I think the video is taking quite longer. Okay, and I don't want to upload too much longer videos. So it is there in the textbook. You just open it and you just look. Okay, so I'll take the help of let me just explain you. ABC. Okay, look here. ABC is equal to, so let's say, let us take AMN. So this angle is also equal, this angle is also equal. We have said this side is also equal, this side is also equal. AM is equal to DE and AN is equal to DF. This is equal. Angle is also equal. These two angles are equal. So by angle side, okay, by SAS theorem, which is there, SAS theorem, we can say these two are congruent. It's a congruency theorem. Okay, SAS congruency theorem or axiom, you say whatever you want. So we can say that these two triangles are congruent. Now if this triangle are congruent, then we can say, let me draw for this one first. If these two triangles are congruent, what the hell line is going where? Array, what the hell is happening with this? So this angle is equal to this angle and this angle is also equal to this angle. Okay, if these two are congruent, then we can say these angles are equal. And another thing is DEF is also equal to ABC. Okay, this is also given in the question. This angle is equal to angle this one, and this angle is equal to this one angle. Okay, so now since MN is parallel to this, MN is parallel to BC, by basic proportionality theorem we can say AB by MN, AM by MB is equal to AN by NC. But in question they are writing a little bit differently. So how they are writing that one, I'll just show you here. Let me write down AM by MB, MB is equal to AN by NC, AN by NC. Okay, now in book they are writing a little bit differently. Okay, you just add +1 here, you get the answer. Okay, it's not that complicated. Okay, if you are going to add +1 and do the reverse, you are going to get. So if you want me to do, then AM by MB plus 1 is equal to AN by NC plus 1. AM plus MB by MB is equal to AN plus NC by NC. So this AM by AM plus MB, AM plus MB, that is AB by MB is equal to AN plus NC, that is AC by NC. Okay, now for getting the, I think we got the question from, I think so, we got directly from, this is NG. What have I done? NC, AN by NC, AN by NC, AM by MB, AN plus NC is equal to NC, and okay, this is okay. Now similarly, okay, I think we don't get the question exactly. Okay, for that, for getting the question exactly, we need to do a little bit different. I'm sorry for that. I haven't looked into the questions. You just do the reverse, MB by AM and NC by AN. Okay, AB by MB by AM and NC by AN. Okay, you just write this way. You take the LCM, MB plus AM by AM equal to NC plus AN by AN. You write this way. Okay, after that, this one is AB and this one is AM, AC by AN, which is given in the textbook. So this, I think this is there in textbook. Okay, before one little bit mistakes there. So this is there in textbook. So I've already found out. You just look it and you just find it out. Now so if that is the case says, let me write down here clearly. Okay, AB by AM is equal to AC by AN. Okay, now AB by DE is equal to AC by DF. How do we get this one? Because AM is equal to D. We have written already AM is equal to D. We haven't written that. AM is equal to DE. We know this. So instead of AM we put DE, and AN is equal to DF. So we have put AN is equal to DF. Okay, done. Now so far it is okay. Now we can say similarly, we can show that AB by DE is equal to BC by EF. We can also show this one. Okay, not that complex. In this case we are going to take the internal by we are going to take the parallel, another one parallel, and we can do it. Okay, and therefore we can conclude AB by DE, these two here, look here very carefully. Okay, AB by DE and AB by DE here both are similar. So you write only one. This is equal to this one. AB by D is equal to this one, and AB is equal to this one. So we can conclude that AB by D is equal to BC by EF is also equal with AC by DF. This is under case 1. Okay, let me not go directly and explain you how the case 2 come. Okay, because I cannot write it here, and it's very difficult for me to explain writing here. Okay, I'm finding quite difficult. So let me directly do case 2 by roughing out this one. I think you understand it. Please open the textbook. Okay, please open the textbook. Please to keep the textbook in front of you. Okay, and please look into it, because I cannot write here. I've told you already. So now, okay, done. Another case, case 2. What was our case 2? Case 2, previous, I've given case 2, AB is equal to DE. Both these are equal. So if AB is equal to DE, then ABC, DEF. So all these are equal. This one is equal to this one. AB is equal to DE. AC is equal to with DF, and BC is equal to with EF. These are equal. So we can directly conclude, this is quite simple, that if all these are equal, then we can say AB by DE is equal to AC by DF is equal to BC by EF. If you don't understand, please let me know, because I'm just going thoroughly in front. Okay. Case 3. What is our case 3? Case 3 says if AB is less than ABC DEF. Let us take BE here, ABC here. Okay, so ABC, this AB is smaller than DE. This is our third case. Now in this case, it is quite similar with the first one. Okay, where we are going to do MN, we're going to make MN such that AM is equal to it, AM is equal to it DE. Okay, these two are equal. Okay, and after that, okay, like in the first case, we can show that AB by DE is equal to AC by DF is equal to BC by EF. Okay, this is what we can show. Okay, now if you happen to learn these 4 theorems, okay, it is compulsory. Okay, I'm telling it once again that if you happen to learn only these 4 theorems, you can attempt at least one question from the given question. 2 questions is to be given by or. Okay, you can attempt any one of those 2 questions, and if you happen to understand all these 4 theorems, then it will be easy for you to understand. Okay, now let me explain other 2 theorems even. Let me make video a little bit shorter. Okay, so that the video is already 47-48 minutes, so I'll just try to make it shorter by directly explaining you from the textbook. Okay, if you find it difficult, just let me know, I'll make the new video for it. Okay, let me not make this video longer. So it is theorem number 7.6, I think so. I've written the question here. So SAS similarity: if one angle of a triangle is equal to one angle of another triangle and sides including this angle are in the same ratio, the triangles are similar. If one angle of a triangle is equal to the one angle of another triangle, if suppose let's say these 2 triangles are the one which 2 are equal, these 2 angles are equal to another one angle of another triangle and sides including these angles are in the same ratio, and these sides are in the same ratio. Okay, these sides are in the same ratio, then the triangles are similar. These 2 sides must be in the same ratio. So let's say this is A, B, C, and this is DEF. Okay, if this is the case, and these 2 angles are equal, and these 2 sides, that is AB by DE is equal to AC by DF. Okay, if this is also there and angles are also there, then these 2 triangles are similar. Okay, let me take the textbook and explain you thoroughly. Okay, I have the textbook here. Okay, let me explain you thoroughly. Okay, so that it won't take much time for me to explain. Okay, I've already given the given condition. What is the given condition here? I've already told you given condition. Given, what are the thing given? Angle A is equal to angle C, and AB by DE is equal to AC by DF. Let me take another page and let me explain you very first thing. Now what do we need to prove? We need to prove triangle ABC is similar to triangle DEF. Okay, DF. Open the textbook, open to page number 140. Okay, let us start directly the proof. It says if AB is equal to DE, this is A, B, C, D, E, F. Like previous question, we can discuss this question also in 3 cases. Okay, we can discuss even this question in 3 cases. Okay, so what might be there those cases? Where is my? Okay, let me. A, B, C, D, E, F. Like previous question. Okay, we can discuss in 3 cases. One case must be AB is equal to DE. Another is AB greater than DE. Another is AB less than DE. So let us combine these 2 and say AB doesn't equal to DE, and first is AB is equal to DE. Okay, so if you look at the proof, the first they are taking the case 1. Okay, case 1. What is the case 1? Case 1 says if AB is equal to DE. If AB is equal to DE, if these 2 are equal. Okay, then AC by DF, AC by DF is equal to AB by DE. Okay, AC by EF DF is equal to AC by DF is equal to AB by DE. Okay, if these two are equal, AB is equal to DE, AB by DE, these two are equal, then it will be 1. Okay, if this is equal to 1, then we can say AC by DF is equal to 1. We can write AC is equal to DF. Okay, AC is equal to DF. If these two, if AB is equal to DE, okay, then this is also equal to this one. Okay, and we can say angle is already equal. This angle is already equal. So by SAS we can say these two triangles are congruent, or these two are triangle are congruent, or you can say it is similar. Okay, it is already congruent. If it is congruent, then it is similar. Okay, that is not a big deal, and you are expert on it. So another, okay, suppose let's say now another case. What is another case? Let me draw for this one. What is another one? If AB doesn't equal to DE. If it is written if AB doesn't equal to DE, then one is greater than other. Without loss of generality, we can take AB is greater than. So we are taking AB greater than DE. Suppose. Okay. We can take less than also, but we are taking AB is equal to greater than DE because it is given in the question. You can take AB less than DE and also prove. Okay. It's not a big deal. Okay. Now take MN here. Okay. MN such that AM is equal to DE. Okay, such that AM is equal to DE. We are taking AM like previous question. AM is equal to DE. Okay, what is another thing? And AN is equal to DF. AN is equal to DF. Okay, in triangle AMN, this triangle, AMN and triangle DEF, these two triangle. Okay, these two triangle. AM, this is equal to this one, and AN is equal to DF. AN is equal to DF. Then if these two sides are equal and this angle is also equal, then we can say that these two triangles are similar. Okay, these two triangles are similar. Now we have drawn MN parallel to BC, so we can write AM by MB is equal to AN by NC. You know, right? It is simple. We can write like this. Okay. Now we know that AM is equal to DE. So AM, okay, AM is equal to AM, or like previous by adding +1 all those things, we can write AB by AM is equal to AN by AC by AN. Okay, let us write this one. I've shown you how to calculate this one before. Okay, in the previous video, in the previous section of previous question. Okay, not the previous video, sorry. So this is AC. Now if you look here very carefully, you can see that AM and AN, okay, AM is equal to DE, and AN is equal with DF. So you can write AB by, instead of AM you write DE, and instead of AN you write DF. Okay, you can write that, is it? Now we have shown already. So we can write MN is parallel to BC, okay, by converse of basic proportionality theorem. This statement is already given in the textbook. What have I done? Oh, sorry for that again. So it is given. Hey, look here. Okay, let me do it. It is given in the question that AB by DE is equal to AC by DF. Now AB by DE and AC by DF. DE is equal to AM. AB by AM is equal to AC by DF is equal to AN. Okay. If these two are so, then we can say that MN is parallel to BC. Okay. If these two are parallel, then we can say that this angle is equal to this angle, and this angle is equal to this angle. So therefore we can say that these two triangles are similar. Okay, therefore we can conclude these two triangles are similar. Please look in the textbook. If you don't understand, please let me know. Okay, let me explain another video because the video is getting too longer. So let me explain another theorem which I'm going to take is Pythagoras theorem. It is very simple theorem. Okay, it's not that complex. Okay, it says in a right triangle the square of the hypotenuse is equal to the sum of the square of the other two sides. Let us take this as ABC. Okay, and let us take this as a right triangle. Now if this is the right triangle, then AB plus AC square is equal to BC square. Hypotenuse will always be opposite to the right angle. Okay, this is hypotenuse here, BC. Okay, and AB square plus BC AC square is equal to BC. We need to prove. Okay, so given triangle ABC where angle A is equal to 90 degree. Okay, another is to prove. What do we need to prove? We need to prove that AB square plus AC square is equal to BC square. We need to prove this one. Okay, construction. What we're going to do as a construction, you just join AD. Okay, construction, you just join AD. Okay, AD, this is 90 degree here. Okay, this is D and this is 90 degree here. Okay, let us join AD. Now we need to prove. How are we going to prove? So proving, you are going to take this triangle. Okay, triangle ABC and triangle DBA. Now if you look here carefully, okay, triangle ABC is like this, ABC, and triangle DBA is like this, ADB. Okay, you shift this angle to the top. Okay, make this angle to the top, then you will happen to see something like this, D. Okay, DAC. Okay, this is the thing which you are going to see. Okay, if you have shifted the angle to the top. Now angle ABC will be equal to angle B. ABC is equal to DBA. D. Okay, this is not C. This is DBA. Angle ABC is equal to angle DBA. BDA. Okay, angle ABC is equal to angle. No, what I have. This angle is equal to this one. Angle BAC is equal to angle BDA. These two angles equal because they both are 90 degree. It is already given. Another thing is angle ABC is equal to angle BD. ABC is equal to angle DB. Array, what the hell? DBA. These two are also similar. So we can say by similarity theorem that these two are similar. Okay, if these two are similar, then what we can conclude? We can conclude that AB by BC, AB by what we can conclude from A, B, C, D. So we can conclude that AB by DB is equal to BC by BA. Okay, AB by DB from these two triangles, okay, is equal to AB. It's equal to BC by AB. Okay. Now if you are going to cross multiply both, you get AB square is equal to BC into DB. Okay. Similarly, if you are going to take another triangle, so let's say triangle ABC and triangle this one DCA. If you are going to take these two triangles like before, if you have to happen to make like this, D is this one, okay, then AC. If it is like this, then also we can write AB by DC is equal to AC by DA. What have I done? Have I written any mistake? Any mistakes? Check it out. AC. AB by, what the hell am I doing? AB by AC is equal to AC by AC divided by, let me write it down, DC. The angle is here, AB by DC, AB by AC. AB by AC is equal to AC. I think I've done some mistakes here by writing this way. It must be AC. AC by AD. Okay. Now AC square will be AB into AD, like previous one. Okay. So if you are going to compare both these, okay, if you are going to equate both these, then we can write AB square plus AC square is equal to, you are going to get BC, okay, A DC plus BD. Okay. Now AB square plus AC square is equal to BC. What is BC here? This is the whole line BC. Okay. BC. DC plus BD. DC plus BD. These two lines. If you happen to add these two lines, you are going to get the whole BC. So it is BC. If you multiply these two, then you are going to get BC square. Okay. So it is quite messy now. I don't know whether my image will give you. So we can conclude therefore, okay, that AB square plus, what was the AB square plus AC square is equal to BC square. Okay. This is the thing which you need to prove. I hope you understood it. If you don't, you just let me know. Okay. I'll make a particular video explaining detailedly. Okay. I just need to go in hurry because the video is getting much longer. Okay. So thank you so much. Okay. Do whatever is needed to be done. We'll meet in the next video.